Hey YouTubers, this is Old John. I'm going to make a video on troubleshooting my landscaping lights. I've got a Malibu transformer and it's only a year or two old. Um, these landscaping lights have been in approximately 10 years. Previous one um, failed, so I replaced it. I'm the second owner of the house, and so I bought this. It's a 600 watt. It's got two legs on it, so you can separate out two strings of lights. Now, problem is, I've got this disconnected at the moment, but this goes down to just one light down here, and I've found that the bulbs in this light down here are not lasting, and I think we've got over voltage, over amperage going that way for these halogen bulbs. And then going the other way, there are 6 lights being served along this line. This is a number 2 wire going to the left and number 14 wire going to the right. Okay, so let's go look at both ends of the lines and see what kind of voltage we're getting. First, I'm going to turn the lights on. Okay, we're going to test the in run. This is the line that's 14 gauge wire, and only one light on it. Now, I'm suspecting that there's not enough resistance in the wire and enough lights that we're getting too much voltage. So let's look at that. These are the bulbs, halogen bulbs, and they're really getting burnt. This one's not a good example. I didn't save one of those, but this is all getting burnt and actually almost exploding. So let's check the end of the wire here, see what kind of voltage we have. And we're looking at AC voltage. These are not DC, this is AC. So holding the prongs on the ends of the wires, it doesn't matter which side is which, but I'm getting a 12.969798 voltage. The maximum voltage on these bulbs is 12, and from what I've read online, you really want to keep it to like 11.5. So that's the clear reason why I'm getting over voltage. And this is basically what's coming out of the transformer too. So there's really no resistance, not enough resistance being supplied by the length of this wire or this one bulb. So I may have to add some additional wire, and I'll talk about that later. So let's go look at the other end that has 6 bulbs on it. So here are the other bulbs, other lamps I mean. There's number 3, 4, 5, and 6. Okay, so I have the end of the wire here exposed and the prongs on it. I've got it on the 20 AC volt scale. I'm 8.3. From what I read online, you want at least an 8.5. So this light is probably dimmer than the other ones. So I need to do something to increase the voltage on this end and decrease it on the other end. Considering taking one of the 6 lights that are on this end and wiring it in to the other end, and then supplementing the number 14 wire on the short run with a long piece of number 16, and see if I can get enough voltage drop to stop burning out that bulb. And by taking off that one lamp off of this run, making it 5, maybe that will increase the voltage to this end and this lamp, that this lamp will actually burn brighter. So what I'm planning on doing is adding this lamp to the other lamp and see if that will increase the voltage drop. I also will add some additional wire. This is number 16, and I'll tie this into the number 14. With wiring, the higher the number, the less capacity it has and the more voltage drop you will get. And in this case, usually you want larger lines so you don't have as much voltage drop, but in my case the wiring is oversized for the application and I want to actually get more voltage drop. Now some people talk about putting in diodes to reduce voltage, or even timers. From my understanding, the NEC codes don't allow you to put dimmers on to reduce the voltage that way, but those are other alternatives. I'm going to try this first. So first need to take this lamp off of the wire, the number 12 wire that's going down and serving all these lamps. And then I will hook this wire into it, run this wire over to the where the number 14 wire ties into the transformer. Tie those together and then run that wire, well, let that wire feed the number 14 over to that lamp. Okay, I'm covering the connection on this second lamp. I got the transformer laying on its back so I can get to where the wires connect. So I'm going to try to attach this wire to here and then up to the transformer, trying to provide enough resistance, and with the addition of this lamp on this line to reduce the voltage to that lamp down there. And so I'm uncovering here to disconnect this from this line to attach to the new, and much to my dismay I've found that there's no connection here other than just literally the wire has been cut on the underground number 12 wire, and the leads from the lamp have just been wrapped around it. That's a terrible connection. I mean, it's lasted apparently for all these years. Usually you have a connector like this. These are an old style, which there's 2 sides. You wrap around the wire and there's little teeth on each side that literally dig into the wire. But there again, these are old style. That's what was on these lines. But here they didn't even do that. I have a newer connector which I'm now using like this, and it's really nice, strong, and durable. But okay, using my wire stripping tool, very simple tool, common for electrical work. I stripped the ends of the wire. Now I'm going to attach them to the transformer. Okay, I hooked the number 16 wires in here to the back of the transformer. Now I'll run these over and bring the wire back. I'll run the wire over to the lamp, hook up the lamp, and then bring the wire back to here and hook into this number 14 wire that's going to this lamp here, and then see what we get. Okay, so I connected the number 14 wire. It's going down to the ground to this lamp, to the new wire, the number 16 wire. I'm running it over to this light, and I'm going to use one of these connectors to connect this to the wire. So I'll do that next. So these connectors have a little blade on each side, and when you squeeze it over the wire, both sides puncture the wire. And so I've squeezed it together. Now I have to attach these wires to the lamp. These lights that I'm putting on are they're low voltage replacement cable connectors, and they're from Hampton Bay. Looks like part number 1001491-871. They work real nice. Show you how to hook them in. Nice product. Okay, so I've got the line connected to the lamp. So let's go turn it on and see what kind of voltage we have. So we have two lamps now on this circuit. Just sitting on the ground. I'll lift up to there when I'm done. But okay, so I got this wire going to this lamp. It's working. Let's see what kind of voltage we have at the other lamp, which is attached to the number 14 wire going underground over to this lamp. I don't have a bulb in this yet, but we can check the voltage. Okay, we still got 12.3 something, but we definitely reduced it some, but not quite enough. We reduced it by about 0.6 of a volt. We need to get it down below 12. So I'm going to have to think about this. Okay, we're going to test the ends of the wire here. Got the leads on the end of the wire. And whoa, look at that. The voltage has gone up from 8.3 to 8.6. And if you recall, I think I said you want a minimum of 8.5. So um, we're looking good. By taking the one lamp off, we've gotten the voltage in the range we want, I think.